Hello, this is Richard Gillespie. Welcome to Perspectives. Today we want to talk about the extinction of the megafauna at the end of the last glacial maximum. This is commonly people think about the extinction of animals like mammoths and saber-toothed cats and large ground sloths and these sorts of animals that seem to have disappeared fairly quickly out of the fossil record approximately 12,500 years ago. And this is, of course, a very interesting topic. These animals had been around since the beginning of the Pliocene, some 5 million years ago. So they had lived through all of the ice ages that have all of the glacial maximums that have occurred ever. These animals lived through every one of them. And it was at the end of the last glacial maximum that they suddenly became extinct. And so there's been a lot of theorizing and research done on as to why this happened. And I just want to update that a little bit. There's a very good program on PBS Nova, which you can see on YouTube, that talks about this mass extinction. But there's been information discovered since that program was made that we can expand on a little bit. So the fellow who initiated a lot of this particular investigation, his name was James Kennett, and he was he still is an archaeologist who was really trying to find out the answers as to why these animals went extinct the way they did. And his research coincided with the research of a fellow called by the name of James West. James West was interested in a geologic layer called the black mat, which can be found around the world from the time of this dying. And this dying happened about 12,500 years ago. And his discovery was that above the black mat, you don't find any fossils whatsoever of these animals that became extinct. Below the black mat, they're doing well. So everything was fine until one very bad day, it would appear, that a layer such as this can be put down in a very short period of time by a major cataclysmic event. And this also coincided with the work of Paul Majewski, who is a researcher on the Greenland ice sheet. And what he found independently at the time of the Younger Dryas was that there was a very sudden change in temperature that within a period of less than 2 years, the temperature in North America, the average temperature in North America dropped by close to 20 degrees Fahrenheit. And that the climate went from being 2 months of winter and 10 months of summer in a climate that was actually warmer than today's to very suddenly being almost 12 months of winter and maybe just a very, very short summer. And this happened in a period of less than 2 years. So that is a very, very sudden event. And so that's curious that this could happen so quickly. And so it narrows down the number of mechanisms that could account for this simply because of how quickly it happened. And what they discovered, the black mat is first of all the most interesting discovery because it implies that there was an impact, extraterrestrial impact. These kinds of layers were discovered, have been discovered at several different times, and the most famous one was the layer of clay that was discovered by Louis Alvarez in the early 1980s that was laid down at the time of the Chicxulub impact that killed off the dinosaurs. So this is a characteristic that, so what can create these layers? And the answer is that when you have a large impactor, that it sprays up a lot of debris into the atmosphere. This debris rains down, and as it rains down, it heats up. and the atmosphere becomes superheated to the point where the vegetation below it will ignite, and you'll start a fire. You'll burn off everything on the surface of the planet. And it's not like a regular forest fire where you have a fire here and there, so you don't get this thick layer. It's everything burns off all at once, so that within a few days you've burned off the entire vegetation on the surface of the planet. It just falls back down as ash, and that's what creates this ash layer. And so that was a very interesting discovery, that that happened at the same time that these animals went extinct. And this also coincided with the temperature change that was discovered by Majewski. So the only thing that was missing was, where's the crater? And since the time that this program was published, the Hiawatha crater in Greenland has been discovered. That seems to be about the right time and the right position on the planet, but is not necessarily big enough to account for the size of the impact that would have been required to put down this clay layer. But the fact that the black mat is there is pretty strong evidence that there was an impact. Even if we can't find the crater, maybe it was partially obscured by ice, maybe it was eroded away, maybe it hit the water, shallow water. It's hard to really say for sure, but the Hiawatha crater certainly makes you think about it. But nonetheless, you can't escape the fact that we have the black mat. So that makes you wonder about how often the Earth gets hit by large impacts. This was only 12,500 years ago, and so that's very, very recent. In fact, it's so recent that it makes you think, if you calculated the probability, how frequent do these things of this magnitude hit the planet? You think, well, it's impossible that it could have done it 12,500 years ago, that it was so close in time to the point where we live, that the probability of it happening within that time period is almost zero. So if that's the case, then maybe the math is wrong. Maybe these things occur a lot more frequently than we think, but they don't necessarily hit on land. They hit in the ocean, or they hit in an area or at an angle, and in an area where where we don't have the big damage. For example, the asteroid that killed off the dinosaurs hit in Mexico, in the Yucatan Peninsula, 65 million years ago. That was a real freak of nature, because not only was the impact big enough, there are only a few places on Earth where it could have hit, and a few angles that it could have hit at, that it would have caused so much damage. It could, if it hit in the ocean and it hit at a steeper angle, the dinosaurs would still be alive today. It just happened that it hit at an area where there was a large calcium sulfate deposit, which is the northern part of Mexico, the Yucatan Peninsula. So it was able to throw up a lot of sulfur. It also hit at a shallow angle. So, and from the south. So it hit at just the right angle and in just the right deposit. So there were a lot of coincidences that happened as when that meteorite hit, that led to the big destruction. Now that makes you think, okay, so that was a real fluke. But does that mean that we get hit with these big impactors a lot more often than we think, and we just don't see the damage from them because they hit at infrequent intervals? They don't necessarily wipe out the planet, and maybe we do get hit much more frequently than we think. And I can say, in my lifetime, there have been a number of large impactors. There has been, the Chelyabinsk impact in 2013 in Russia. And in the early part of the 20th century, we had another big impact in Russia. Tunguska. And if you remember, in 1994, we witnessed a comet colliding with Jupiter, the Shoemaker-Levy 9. So what are the chances that in one person's lifetime you would be able to see a comet that, had it hit Earth, would have been an extinction event, huge extinction event for Earth, but we were able to witness it hitting Jupiter? I mean, that the odds of that happening are astronomically small. Or it means that these things happen a lot more frequently than we know of, than we think. And my suspicion is that, all of these coincidences probably mean that the frequency of impacts is a lot greater than we think it is. And we just don't see them because a lot of them hit in the ocean, or they're hitting the outer planets and this sort of thing. But I mean, it's just incredible how many extinctions, or how many impacts have happened just in the last, let's say 65 million years is a fairly long time, but nonetheless, maybe these things are a lot more frequent than we think. And it looks like these kiloton asteroids like Chelyabinsk and Tunguska, these happen once or twice every century. That's what it looks like. These are big enough to wipe out major cities. But they don't. The chances of hitting a city are extremely slim. But they are big enough that they could wipe out a city. So this is very interesting, and this work that this team did on the extinction of megafauna in North America, that's very, very interesting. And we'll see what future investigations bring to the surface. But it's interesting that we could be getting hit with major impactors a lot more frequently than we think.